By 2050, there would be more than 9.7 billion people on Earth.
And it would become difficult to feed such a huge population.
Our research shows us that a large fraction of farmers use excessive inorganic fertilizers and pesticides. This excessive usage is harmful for the crops. Moreover, the pesticides contain toxic chemicals that have negative effects on the human health. Increased and unnecessary usage of fertilizers makes it hard for the plant to absorb water. They can also make a completely healthy plant dried up. Above all, pesticides tend to degrade the soil and contaminate it. These problems are quite serious and they have a negative impact on the crop yield. We think that the fertilizers and pesticides should only be used on the crops that require them. This would increase the crop yield as their reduced usage would reduce their negative effects as well. But it is a very troublesome task to manually survey every single crop on the field just to check if it is healthy or infected. So, we have thought of an interesting solution to make this troublesome task trouble-free. Healthy vegetation absorbs blue and red light energy to fuel photosynthesis and create chlorophyll. A plant with more chlorophyll will reflect more near-infrared energy than an unhealthy plant. Let us look at it more closely now. This is a healthy plant, so it is obvious that it has a high chlorophyll content. It absorbs blue and red light energy to fuel photosynthesis and reflects green and near-infrared light energy. Because of the high content of chlorophyll in this plant, the rate of reflection of near-infrared energy is high. This is an unhealthy or an infected plant. So we know that the content of chlorophyll in this plant is less. Blue and red light energy would be absorbed and green and near-infrared light energy would be reflected. However, this time, the rate of reflection of near-infrared energy would be much lesser than it was in the healthy plant. The difference of the reflection of near-infrared energy can be detected by using a thermal camera. By analyzing these differences, we can identify and differentiate the healthy plants from the infected and the unhealthy ones. So, to perform this process autonomously, we are going to use a drone, which would be equipped with a thermal camera. The farmer would launch the drone, and when it reaches a certain height and stabilizes, it would start its thermal camera and look for near-infrared radiation. The drone would construct a thermal heat map by actively analyzing different thermal signatures present on the farmer's field, using what we like to call an intelligent image processing program. This heat map would be used in differentiating and identifying the healthy, infected, and the unhealthy crops. The amounts of fertilizers and pesticides to be sprayed would vary according to the type of plant we're dealing with and with the degree of infection and the health conditions of the crop. So, the drone would automatically calculate the amount of pesticides and fertilizers to be sprayed by using the data from the thermal map it generates. From the thermal camera that our drone is equipped with, healthy plants would be viewed as the source of highest near-infrared radiation as they contain the highest amount of chlorophyll. Being healthy, these plants would not require high amounts of pesticides and fertilizers. Infected plants would be viewed as the source of the least near-infrared radiation, as the pests would have hampered the photosynthetic abilities of the plant by damaging the leaves and its other parts. These crops would require an immediate spraying of pesticides and fertilizers, which would be sprayed in appropriate amounts. The near-infrared radiation emitted by the unhealthy plants would sit somewhere between the radiation levels of healthy and infected plants. These plants would require midget amounts of fertilizers and pesticides, which would be sprayed according to the degree of unhealthiness. The drone will send daily reports which would state the condition of the crops to the farmer's tablet. The farmer can use this report to keep a check on his crops and make sure that his crops grow in the most efficient way. Once it identifies the crops, it would use its intelligent image processing program to identify the areas of interest. The condition of the crops would be indicated by using a specific color scheme. The drone will then automatically spray the required amounts of pesticides and fertilizers on the infected and unhealthy crops.